When we implemented the add algorithm, we had to decide, were we going to chain collisions together, or were we going to use open addressing to handle collisions? And that decision impacts the rest of the hash table. So for example, when we want to remove an item, what we're going to do is remove the item by key. So we stored an object with the key Jane, which represents the value that is the person object for the user Jane. With open addressing, this is the case where, in the case of the collision, we move the object forward. What we say is, let's get the index of where we think that object should be. So we think Jane should be at index 3. If the value at index 3 is non-null, check if it's Jane. If it is Jane, remove it. But if it's not Jane, let's assume a collision might have occurred and go check the next index. Now we kind of repeat here. If that next index is non-null, if it's Jane, remove it. If it's not Jane, continue. And we keep on doing this until we either find a null entry or we find Jane. But this does get more complex. If you had multiple collisions that all cause the walk forward, when you remove an item, you create a null slot. And now what you have to do is look at every non-null item after that item and figure out if it was a result of a collision. And if it was, you have to re-add it back into the table. And this gets really kind of tedious to maintain. And it's why I'm not a big fan of open addressing when implementing a hash table for teaching. What I prefer is chaining. And this is because it's a lot easier to conceptually understand. And the point of this is not to understand all the subtleties of open addressing. The point of this is to understand hash tables. So let's not focus on open addressing, let's focus on chaining. All you do with chaining is you get the index for the key that you're looking at. So we get the index for Jane, index 2. And then we look at index 2. Is there a linked list in that index? If there is, then look and see if Jane's in it. And if she is, take her out. And if there's not a linked list there, then Jane's not there. So there's nothing to remove. It's much simpler. There's nothing else you need to do. If Jane is in there and 3 other things are as well, it doesn't matter. The linked list will manage that for us. We can focus on the hash table.